Hello everyone, my name is Naina and I'm from the Buddhi Academy. So today we'll see the last part of the chapter, that is some basic concepts of chemistry. So in our last video we have seen about the molar mass, atomic mass, formula mass, mole concept and molar masses of the atoms or molecules. Now then we have also seen how to reduce an empirical formula or molecular formula from the percent mass of a molecule. So today we'll see what is a limiting reagent. So many times reactions are carried out with amounts of reactants that are different than the amount as required by the balanced chemical reaction, right? So in such situation, one reactant is in more amount than by the balanced chemical equation. So in a balanced chemical equation, so for example here, before balancing it, we only had one Fe ion reacting with two oxygen molecules, right? And the product we got had more number of reactants. So in such cases, we balance the reaction. So when the reactant which is present in the least amount gets consumed after some time, and after that further reaction does not take place, whatever be the amount of the other reactant. So what happens, if there is two reactants, now if I have Fe plus CuSO4, this will make FeSO4 plus Cu. So whatever amount of Fe is present, if this Fe is completely taken up by the SO4, the remaining CuSO4s will remain the same, will remain there only, it won't change. So the reactant which is present in the least amount, if Fe is present in least amount compared to CuSO4, the least amount gets consumed after some time, and after that further reaction does not take place, whatever be the amount of the other reactant. Now if Fe is consumed completely, or Fe has completely formed into FeSO4, and there is few of CuSO4 molecules present, then it will be present like that only, because no more Fe is present there to convert it to FeSO4, right? So hence the reactant which gets consumed first limits the amount of product formed and is therefore called the limiting reagent. So Fe here is the limiting reagent, as it limits the formation of the product, because if all of the Fe molecules are consumed, then the reaction will end there, because no more further FeSO4 will be formed, right? So this is the limiting reagent. Okay, now till now we have seen about the solids like atoms, molecules. Now what are the reactions in solutions? So a majority of reaction in laboratories are carried out in solutions. So therefore it is important to understand as to how the amount of substance is expressed when it is present in the solution. So in our labs, many of the reactions are carried out using liquid solutions like HL, HCl, H2SO4, HNO3. All these are liquids, right? So how we measure them, how we take them, what is the amount of substance, how we express them. So it is important to know all these things. So the concentration of a solution or the amount of substance present in its given volume can be expressed in any of the following ways. So it can be expressed in any of these following ways, that is mass percent or weight percent, mole fraction, molarity and molality. So let us now see each one of them in detail. Now here you all know how to balance a chemical equation, right? Balancing a chemical equation was taught to you all in the 10th standard. Now these are the problems where you have to calculate the amount of water produced by the combustion of 16 grams of methane. Here you have to first balance the equation and then you have to calculate them. Okay, so first one is the mass percent. First is the mass percent. So it is obtained by using the following relation. So mass percent is calculated by using this formula. So what is the formula for mass percent? It is mass percent equals mass of solute divided by mass of solution multiplied by 100. So for example, a solution is prepared by adding 2 grams of a substance A to get 18 grams of water. Calculate the mass percent of the solute. Now here you have asked the mass percent of the solute, right? So mass percent of A equals mass of A. A is the solute, right? Mass of A divided by mass of solution multiplied by 100. Now here it is said that a solution is prepared by adding 2 grams of substance A. So 2 grams of substance A, mass of A is 2 grams divided by mass of solution is 2 grams of A plus 18 grams of water. That is the mass of solution. How it became 18 grams of A? Because 2 grams of substance A to 18 grams of water. It is mixed with 18 grams of water. So combining both will give you the mass of solution multiplied by 100. So it is 10% of solute is present. So this is how a mass percent is calculated. Now next is the mole fraction. Now what is a mole fraction? It is the ratio of number of moles of a particular component to the total number of moles of the solution. Now mass of mole fraction is a ratio of number of moles. Moles means number of atoms of a particular component to the total number of moles of the solution. So if a substance A dissolves in substance B and their number of moles are Na and Nb, so the number of moles is denoted by small n. So if a substance A is dissolved in substance B and their mole numbers will be Na and Nb respectively, then the mole fraction of A and B are given as, so how we will calculate mole fraction of A? So mole fraction of A will be number of moles of A divided by number of moles of the solution. So total number of moles of solution, so it will be Na divided by Na plus Nb, because the solution has both substance A and substance B, right? So number of moles of solution, so it will be Na plus Nb. Now if you want to write for mole fraction for B, it will be Nb divided by Na plus Nb. So this is mole fraction for B. Now next is molarity. Now it is the most widely used unit and is denoted by capital M. So molarity is denoted by capital M. It is defined as the number of moles of a solution of a solute in 1 liter of solution. So what it is defined as? It is defined as the number of moles of the solute in 1 liter of solution. When it is present in 1 liter of solution, it is molarity. So the formula is molarity equals number of moles of solute divided by volume of solution in liter. So this is the formula for molarity. Now what molarity is? It is the number of moles of the solute in 1 liter of solution. So number of moles present in 1 liter of solution. The formula is number of moles of solute divided by volume of solution in liters, because it is present in 1 liter, right? Suppose we have 1 molar solution of a substance, say NaOH, and we want to prepare 0.2 molar solution from it. So for 1 molar solution we have to prepare 0.2 molar solution. Then 1 molar NaOH means 1 mole of NaOH present in 1 liter of solution. That's what we said here, right? Number of moles of solute in 1 liter. So 1 molar means 1 mole of NaOH present in 1 liter of solution. So for 0.2 molar solution we require 0.2 moles of NaOH dissolved in 1 liter of solution. So how many moles you want, that many moles in 1 liter of solutions. Hence for making 2 molar solution, from 1 molar solution we have to take that volume of 1 molar NaOH which contains 0.2 molar of NaOH and dilute the solution with water of 1 liter. So we have to take 0.2 mole solutions from 1 molar solution. So whatever 1 molar solution is prepared, we have to take 0.2 molar. We have to take that 1 molar NaOH solution which contains 0.2 mole of NaOH and dilute that solution with water to 1 liter. Now how much volumes of concentrated 1 molar NaOH solutions be taken which contains 0.2 moles of NaOH can be calculated as follows. So how we have to calculate this? If 1 mole is present in 1 liter or 1000 ml solution, then 0.2 mole is present in 1000 ml divided by 1 mole multiplied by 0.2 mole of solution. So it will be 200 ml. So from this 1 molar solution, we have to take 200 ml solution so that it makes the 200 ml of 1 molar NaOH are taken and enough water is added to dilute it to make it 1 liter. So when we take 200 ml from that 1 molar solution and make it to 1 liter, dilute it to 1 liter, it will become 0.2 molar solution. So here we use the formula to calculate it is M1 V1 equals M2 V2. So what is M1? So a general calculation formula, M1 V1 equals M2 V2, where M and V are molarity and volume respectively can be used. So here M is molarity, V is volume. Okay, so in this case M1 is equal to 0.2, volume is 1000 ml because it is 1 liter, multiplied by M2 will be 1 molar and V2 we have to find. So we have to cross multiply and we get the answer is 200 ml. So here we commonly use this formula, that is M1 V1 equals M2 V2. Note that the number of moles of solute NaOH was 0.2 mole in 200 ml and it has remained the same, that is 0.2 even after dilution in 1000 ml, as we have changed just the amount of solvent and have not done anything with respect to NaOH, but keep in mind the concentration. So here if you make it to 1 liter, 2 liter, the 0.2 ml or the 0.2 gram of NaOH, it won't change, it will remain the same, the 0.2 molar, because we have only added 200 ml, so it will be only 0.2 molar of NaOH in entire solution. Now next one is the molarity. Last one in this chapter is the molality. So it is defined as the number of moles of solute present in 1 kg of solvent. In molarity it was what? Number of moles of solute in 1 liter of solution. Here in molarity it is number of moles of solute present in 1 kg of solvent. It is denoted as small m. So molality is denoted by small m and molarity is denoted by capital M. Thus the formula of molality is number of moles of solute divided by mass of solvent in kg. Okay, so for example, the density of 3 molar solution of NaCl is 1.25 grams per ml. Calculate the molality of the solution. Now you have given the molarity, that is 3 moles per liter. Mass of NaCl in 1 liter solution is 3 multiplied by 58.5. By 58.5 we have calculated the mass of NaCl. So it will be 175.75. Then mass of 1 liter solution, 1000 multiplied by 1.25. By 1.25, NaCl is 1.25 grams per liter. So this is the density. Okay, it is the density. So 1000 divided by 1.25, you will get 1250. So mass of water in solution, you have to subtract 1250 and the mass of water in solution, that is 75.5. So you will get an answer of 1074.5. Now you know number of moles present in the solute, and you know the mass of solvent in kg. To convert this into kg, that is divided by 1000, so you will get 1.0754. so the molality is 2.79. Often a chemistry laboratory, a solution of desired concentration is prepared by diluting solutions of known higher concentration. So the solution of higher concentration is also known as stock solution. Now in chemistry laboratories, you will always see that any solution you use for a practical thing, you use a diluted solution, and you dilute it from a concentrated solution or highest concentrated solution, and this high concentrated solution is known as stock solution. Note that the molality of a solution does not change with temperature, since the mass remains unaffected with the temperature. So the molality will never change for a solution. So this is all about the chapter. So in this chapter, the important things you should remember is the nature of matter, how they are classified. Okay. So from here you should remember these are all the important parts of this chapter, that is nature of matter, states of matter, how they are classified, then properties, how physical and what is physical and chemical properties, differentiate between them, then how a physical property is measured, what are the base units, then you should remember mass, weight, how they are different and what is how their units are given, then volume, density and temperature. Then uncertainty in measurement, you should know what is a scientific notation, how it is notated, how a scientific notation is multiplied or divided, how it is added or subtracted, what is a significant figure. You should remember these rules of significant figures, then their multiplication, addition, division, subtraction and all of significant figures. Then dimensional analysis, what is a dimensional analysis, then the laws, the 5 laws of chemical combination, that are law of conservation of mass, law of definite proportion, Avogadro's law, multiple proportion, Gay-Lussac's law. Then Dalton's atomic theory, you should know what is atomic mass, how to calculate it, average atomic mass, molecular mass, formula mass, how to calculate all these masses. Then molar concept and molar masses. Percent composition, you should know how to calculate a percent composition, and then you should know using this percent composition how you will reduce a empirical formula for a molecular formula. So this problem I have explained you. Then what is a stoichiometry and stoichiometric calculations. Then limiting reagent, what is a limiting reagent. Then how a solution parameters are calculated, that is mass, percent, molarity, mole fraction, molality, how these are calculated. So these are the things that you should know about this chapter. So thank you for watching my video. Please do like, share and subscribe to our channel.